If you haven't already heard of DNS hijacking, then it's something that you need to be aware of. But more importantly, it's something that you need to be taking action against. Basically what happens is somebody intercepts a DNS query and sends back a false IP address. So instead of you connecting to, well, YouTube, for example, you actually connect to a malicious website. And it's basically possible because DNS, it doesn't have any security built into it. There's no validation checks. There's no encryption going on at all. It's just a fire and forget process. Your computer will be configured with an IP address of a DNS server, so it asks that server to do DNS resolution, and then it just accepts that the IP address that comes back is legitimate. It doesn't check, who sent it. It doesn't check to make sure it hasn't been tampered with anyway. And like I said, there's no encryption taking place anyway. So it's a case of, how do you protect against that sort of thing? Well, fortunately, this sort of stuff was in the papers for quite a while. So the people out on the internet, what they did is they introduced DNS security extensions. And that means that the public DNS servers are actually protecting against this, or at least most of them should be. And what they do is they validate each other to make sure that they are valid DNS servers that they're actually communicating with. But the problem is our connection to the internet. Because if we're connecting to a DNS server and that DNS server is on the public internet, but we're not using something like DNS security extensions, well, that means our DNS queries could be intercepted and we're at risk of DNS hijacking. But also that connection, chances are it's not encrypted either, which means somebody could profile what your computer's up to, what your internet surfing habits are, and so on. So how do we actually guard against this? How do we protect our DNS queries by using something like pfSense, for example? Well, check out this video, because it's a lot easier than you might think. Now, I don't want to get too involved in trying to explain how DNS security extensions work, but at a sort of like a high level, this is what you could expect. So we've got a computer down here that's using traditional DNS, so UDP over port 53, and it just sends that request to a DNS server. So this is an internal DNS server that we've got here. So it doesn't matter whether it's a business, whether it's your home. It'll be a case of this computer just sends a request out for a DNS resolution, and then it waits for this server to respond. So there's no checking taking place at this point here. And chances are this DNS server itself is then sending a query out to an internet DNS server. So I mean, this could be your own internal router, for example, that connects to an ISP. It could be an Active Directory domain controller on a business's actual network. The whole process is the same if they're relying on traditional DNS. There's no checking taking place here, and there's no checking taking place there. Now, that server out on the internet, it's actually capable of supporting DNS security extensions, and it's probably using that when it goes out and queries other DNS servers that are out there. But if this computer here isn't actually prepared for DNS security extensions, well, yeah, there's always that potential where somebody could send back an IP address quicker than this one replies, and it ends up with this computer ending up on a malicious website. Now, fortunately, pfSense, which is a good example because it's very easy to configure. It's a case of, well, let me show you, because it is very simple to actually implement. Now, out of the box, pfSense will actually act as a DNS server as well as a DHCP server. By default, this feature here, DNS Resolver, is actually enabled. So, I mean, we've actually got a choice of DNS services. We can have a DNS Forwarder and we can have a DNS Resolver. We're not interested in the DNS Forwarder. It seems to be going out of favor. The actual DNS Resolver has got way more features. So this is a DNS server for internal purposes. The idea is you would actually get your computers to talk to pfSense for internal DNS resolution. And that's just going to function straight out of the box. It's listening on port 53. You don't have to do anything to enable that. Even the DHCP services, it's already automatically set up to start handing out IP addresses. It's very much a plug and play solution. So when it comes to actual DNS security and DNS forwarding, I have had to make a couple of tweaks, but what I have actually also done is I've just made a bit more slight changes when it comes to the interfaces, because by default, what pfSense does, it listens on all interfaces and it sends DNS requests out on all interfaces, but I don't want it to do that. So what I've done is I've restricted it so that it only listens on the LAN interface, but also on its loopback interface. Now, if you've got multiple interfaces, it's a case of, whatever interface that you've got PCs plugged into, for example, then you need to make sure that's enabled on those. But it has to be enabled on the local host interface, this loopback interface, because pfSense will actually use that DNS service itself. So that's why we have to have that selected as well. And then when it comes to the outgoing interface, well, in my case, I just need to point it to the WAN interface, and that's it. Now, out of the box, it doesn't act as a DNS forwarder. So I have actually, I have had to actually tick that box there which says enable forwarding mode. Without it, my PC is going to make an actual DNS request. It's actually interesting because the way it's set up is that DHCP automatically will tell an actual PC to use this as its actual DNS forwarder, as well as its an actual default gateway. But then DNS won't work if it tries to connect to the internet. So I've got to tick that box to say enable forwarding mode. And when it does that, it's then reliant on whatever I've set up in the, the general setup, for example. So if I go back to that general setup page, I've got this set up to actually go and talk to two servers belonging to Cloudflare. But what it means is when my PC here tries to connect to something on the internet, it talks to pfSense and specifically to the DNS resolver. Because pfSense doesn't know, what these IP addresses are for any public services, it'll then go out to Cloudflare, resolve the IP address, and then it'll hand that IP address over to the actual PC. But the interesting thing is this option here, which is for DNSSEC, which is the DNS security extensions. It's actually enabled by default. I mean, this thing on its own means that the firewall itself was actually going out to the internet, to those servers, and it was actually performing DNS security extensions. It was checking, validation of the actual Cloudflare servers. So, for example, I've got actual two PCs. I've got two different ones. One's an actual Linux computer. What that one's doing is it's actually running TCP dump. So I'll just log into that one. See if I can remember the password again. Yep, didn't type properly. So this one should actually be just sitting there listening. Nope, still not working. Right, there you go. So this one's actually sitting listening on the virtual switch that sits between the firewall and the internet. And you can see these DNS queries going out. You'll see things like the RRSig, DNS keys. These are all to do with that DNS security and extensions. But then, of course, you'll have the normal sort of like requests for, to resolve an FQDN, for example. There's quite a lot of that going on. There's even, interesting enough, even though I've actually got DNS, or rather IPv6 disabled, I'm still seeing these requests from one of the actual Linux boxes for IPv6 addressing. But either way, the point is this is all public information. You can see there's a request going out for safebrowsing.brave.com, for example. That's all going out to the internet because all pfSense is doing, it's performing those validation checks, but it's talking to the servers using UDP port 53. So you can see requests coming back on the domain port, which is port 53. You'll see requests going out on port 53 as well. So all of the actual DNS queries that we're seeing are all public knowledge. If I just go back to my Windows computer, that'll be a bit easier probably. If we go to, see if we can find one of them on that one. So there's a standard query. So it's making queries for whatever that fastly.net's got to do with it. So it's actually asking for those sort of queries. If I go back to the PC just to make life a bit easier, I'll make a request for, let's try Microsoft, for example. See if we can get to Microsoft from here. So we're connecting to Microsoft, so we should see that in here somewhere. We'll scroll down. The trouble is there'll be a ton of different things in there because there's all sorts of places these web browsers go to whenever you log in. I mean, there's like, you've got live.com, that belongs to Microsoft. There's all the ads and everything that you get. That is the downside. Traffic managers, you name it. I mean, all I wanted to do was a DNS request to get to Microsoft. But you can see all of this sort of stuff. It's all public knowledge. So there you go. There's a request there for Microsoft Windows.net, for example. But it's that's the joys of Windows. You think you think you're going to connect to like www.microsoft.com, but there's a ton of other servers involved, for example. And it's going to be fair, it's going to be the same no matter where you go, because they're all using ads out there somewhere. But yeah, so that's always fun. So no matter what I look at, I'm seeing a ton of DNS requests going on, and that's all public knowledge. So out of the box, effectively, I mean, DNS security was enabled, or DNS security extensions, I should say. All I've had to do is make sure that the DNS querying forward is enabled, and then I've just tweaked it a bit to be a bit picky in terms of what what ports, what interfaces we use. But what we can do is we can actually encrypt all that. So that means that if somebody gets in our path, basically, whether it's the ISP, I mean, I've heard talk of potentially even ISPs using that and feeding back ads, for example, based on your traffic browsing habits. I'm not even going to get into the politics when it comes to ISPs and governments in terms of what they're listening in on. But when it comes to pfSense, it's pretty simple. There's a box down here which says use SSL/TLS for your outgoing DNS queries. Because out of the box, basically, DNSSEC has been set up for the validation. So you've got the checks going on. Is this legitimate? I mean, if go back to here, we should have had DNS keys being exchanged at some point. Let's see if I can find any of those. You normally can find like RSIG references and all sorts going on here every now and again. So I do know it is actually checking. Yeah, it's just too many to find there. But it is, at least I know it does that. I know it really wasn't really much for me to do. But what I can do as well, just to make things more secure, or give me the privacy that I'm looking for as well, is basically tick that box. Now, this firewall, it's not a particularly beefy firewall, I must admit. I was just setting it up just for the sake of testing the process. So it's going to take me a while to get the actual change applied. So all I've done effectively is tick the box. I'm going to click save. I'm going to wait for the hamster to run round on its wheel, wait for the paint to dry, and so on. Eventually, I'll get an option to apply that config. I'll apply that, and then once this is all been configured, and we've switched over to using what is DNS over TCP, I'll bring it back. Right then, so that managed to sort itself out. Now, if we're looking back on this old data, we've got connections that are going out from our pfSense firewall off to Cloudflare, and it's using, UDP port 53, for example. But if I scroll right the way down here, see if I can grab a hold of that scroll bar, what you can see is a load of TCP connections now going on. And you'll see references to domain-s. That's how TCP's telling us, what the port is. It's TCP port 853, DNS over TCP. And it means that now all of this DNS querying is actually encrypted. I'm going to say, a lot of connections going backwards and forwards as as DNS resolution takes place, but it's now all encrypted, which means that anybody in the path between me and Cloudflare has not a clue what my DNS requests are, because pfSense is actually connecting to Cloudflare's server, and then it's negotiating a secure encryption tunnel, effectively using TCP, port 853, TLS version 1.3 as it turns out, and it's encrypting everything. So yes, somebody will be able to tell that I'm connecting to Cloudflare, but they've got no idea about what DNS requests I'm making, for example. If I go over to the Windows computer, you'll see TLS version 1.3, application data coming back, and encrypted application data. So it means that nobody in the path can figure out what it is that I'm up to when it comes to DNS requests. So not only are we now validating and making sure we're connecting to, Cloudflare's actual server, and that the responses coming back are from that Cloudflare server. Because we've got all the three-way handshakes going on, the exchange of information, there's a cipher exchange and so on going on. There's only basically the pfSense server, or firewall I should say, and Cloudflare have any idea about my DNS queries, because once they hit Cloudflare would then go out and it'll perform its own DNS queries out on the public internet, so it doesn't get traced back to me, for example. Again, you can argue about the politics and whatever as much as you like, but the idea here is it's a lot safer in the sense that the actual request, the DNS request itself, can't be intercepted, and nobody can actually monitor what it is that you're up to. So it's both secure and it's private now, and that's didn't really take a great deal of effort, to be honest, while I'm using pfSense. I mean, there are other solutions out there that will do that. There's actually companies who are selling security solutions out in the cloud, where basically what you do is, if I go back to the diagram, essentially what you could do, for example, is you could have your own internal DNS server. I mean, say an Active Directory domain controller. You put like an actual appliance on your network, which is effectively their DNS server. That your Active Directory server talks to their DNS server, and then your DNS server goes off and talks to their cloud DNS server. So it keeps all your internal DNS queries private within your own network as such. I mean, yeah, if somebody hacks your network and you're still using UDP53, they'll be able to learn it. But when it comes to getting access to information on the internet, that's all encrypted. And in our case, this is a pfSense box, and now it's a case of our pfSense firewall is actually talking to Cloudflare's server, and it's encrypting the actual session as well as validating that we're talking to the actual legitimate Cloudflare server. So that's a heck of a lot more secure as far as I'm concerned, and it didn't really take a lot of effort to do. Now, if we go back to a previous video that I did, which was setting up my own DNS for a lab, what I can actually do is I can take advantage of this, because what's happening is my DNS server is just doing everything. The way I set it up, it was that it's the internal DNS server, but it's also the DNS forwarder. So what that's actually doing is it's going out to Cloudflare, but it's using UDP port 53, so there's no encryption taking place. So because there's a pfSense firewall in the path, I can actually make a couple of tweaks, if you will. At the moment, the firewall is actually using that internal DNS server to do its DNS resolution, and then the DNS server is going out to the internet. But I can actually flip that round, similar to the way I was explaining before, where I can actually have pfSense can actually act as the public DNS forwarder, and then the DNS server can talk to that. So it'll encrypt all of my actual public DNS information. So I'll flip over to that, and I'll show you how we'll do that. Well, we're now on my management PC, which has got access to the firewall in my lab as well as the DNS server. So if we jump onto the DNS server here, you can see that it's been set up to use the two Cloudflare servers. So basically what will happen is a DNS request will come into this server, and if it doesn't know what to do with it, it basically forwards it off to these two. What I've also done is on this firewall, if we have a look and see what its DNS forwarders are, well, it's that one there. So the firewall's actually going back to that DNS server, because that's the way I set it up. I wanted to have everything running off the actual DNS server that was local. But what I can do is I can flip this around, where pfSense is actually the DNS forwarder for the public internet, but it's going to take quite a few tweaks basically. So for one thing, I need to change this. I need to get this to actually point to the internet instead. So if I put in say 1.1.1.2 for example, and I'll add another one, which is the backup, which is 1.0.0.2, so that should be that. So this firewall now is actually going to go off and talk to the Cloudflare itself. I mean, it didn't actually need to do any internal DNS resolution, to be fair, but it's a case of now it's gone off and it's just talking to those Cloudflare servers. Now, another thing I'm going to have to change is the actual rules, because, well, I'm not allowing access to this firewall. So if we go over to the infrastructure network, what I've got is an actual rule where I'm allowing, say, like TCP UDP from that specific server to these internet servers based on port 53. I'm also allowing TCP from that server to those same internet DNS servers, but for port 853. So that's the DNS over TLS or DNS over TCP. But I actually need to add in a rule to allow that server to get access to the firewall now. So we'll add that in. I'll put that at the top. So we're going to allow TCP because I'm going to be, well, actually I need to allow both because it might decide to try and connect on TCP and UDP. So I'll allow both for this, and I'm going to say that that's this firewall. Sorry, that's that. It's the DNS server. So type. So that's any DNS server effectively that I've put into this group. The destination is the firewall itself. So fortunately, that's an easy one to do. And then when it comes to destination ports, what we want is either or. But what I can do is I can just put in those DNS ports that I had listed. So that's the internet DNS ports. So I'll just say allow DNS access. So that goes right to the top of the list because I picked it, at least I think I picked the top one. Yeah. So we'll apply that change there. So that's the first rule in the list basically on the infrastructure side. So it's allowing that specific server. It is a group I've set up effectively. It's what pfSense calls an alias, but it's at the moment it's just containing that one specific IP address. And it's allowed access to the firewall, which is now running, a DNS service, and then it's allowing access to those ports. Now we're only going to be listening on DNS port 53, UDP port 53 basically. But if we go over to the DNS resolver, I'm going to enable that because I actually need it now. So it's a case of right, okay, we need to run that. I need it on the infrastructure interface. I need it enabled on the local host interface as well. When it comes to outgoing, we'll send it out the WAN. So by default, it's got enabled DNSSEC support. I do want to enable the forwarding, and I also want to encrypt the sessions as well. So that should be it. So we'll click on save on that one. So that should be a bit, yeah, that's a lot quicker. This one's got a bit more processing power compared to the temporary one I'd set up. So at the moment, this is now acting as a DNS resolver, or a DNS server if you want really, and it's listening on UDP port 53, specifically on that infrastructure interface, but also on its own internal loopback interface basically. We're only interested in sending out DNS queries at the WAN port. As you saw, by default it already had DNSSEC enabled. So what I've done is I've just ticked these two. So yep, we want to be doing DNS queries. So I want the DNS server to be able to do forwarding queries out of the internet through this pfSense firewall. But I also want those outgoing requests to be, well, encrypted basically. So that should be it as far as this goes for the firewall. So we'll jump over to our actual server here. So we're still allowing this to work on the actual internet. So this can still use the internet forwarders at the moment, but we've actually got to go and change this. So we want to change, well, actually I'll just edit that line. So this is the named options file, named conf options. So this is basically how I'd set it up before, but what I want to do now is I want to change this. So I'm just going to comment that line out. I'll leave that out for the sake of now, in case I want to roll it back. But what I can do is I can put in 172.16.17.254. At least I think that's what its IP address was, 17.254. 172.16.17.254. Right, okay. 172.16.17.254. So sudo systemcl. Now we'll restart the bind service, or bind9 to be specific. Then we'll actually go and check to make sure that it's still working. Oh, failed. Something was wrong there. Oh, it did not like that. Okay. So let's have a look at that named conf. I think I know what it was. Yep, I didn't put a semicolon at the end. So there you go. So we'll restart that again. I mean, technically it's not started anyway, but you know. Right, so then we'll check its status. Right, so that's now running. So if we go to this computer, let's see if we can get to, let's try Cisco for a change. So we'll see if we can get to cisco.com. So it doesn't like that for some strange reason. It's having trouble resolving it. So let's see what we get if we. Oh, there you go. Right. So it just took a while to sort itself out there. It was having a bit of a think about it. So if I try yeah. So the actual server itself's resolving things. So here I think I might have just had a bit of a hiccup there. Let's try, well, actually, let's try, what the heck, let's try pfSense.com. Oh, so it's pfSense.org, okay. I'll have a look on their blog, why not? So that's all working, but the question now is, well, is it really working? I mean, we've got a DNS server that's pointing to this. I mean, we've got everything, you know, all the tick boxes. And I don't have an actual machine in front of this to actually monitor things. But what I can do is, for example, if I look at the states, so we're going to diagnostics states. Let's see if I ask for the WAN interface. If I ask for connections to say 1.1.1. Well, actually, yeah, 1.1.1.2. So there you go. So we've actually got connections going out on port 853 to 1.1.1.2. We ask for the ones that are going to 1.0002. So that's all we're doing is it's just opening all of these different connections, and then you've just got to wait for them to time out effectively. But what it means is that this DNS server, anybody who comes to this DNS server now, it'll do its own internal resolution. But if it doesn't know, instead of going direct to Cloudflare, it's going to pfSense, and then pfSense is connecting out to Cloudflare, but it's encrypting, and it's all actually validating the sessions between them. So that's good, I must admit. That's made my life easier. It means I don't have to now figure out how to actually get bind actually working with DNSSEC, because that's supposedly quite difficult. Whereas pfSense, much simpler. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, because that encourages YouTube's algorithm to suggest it to other people who might find it useful as well. If you're new to the channel and you'd like to see more content like this, then yeah, do subscribe. Just remember to click the little bell icon though, that way you'll get notifications when I send new content out. If you've got any comments, any suggestions, if you want to leave any feedback at all, please post that in the comments section below. And if you'd like to support the channel, I've left links to both Patreon and PayPal in the description below. But above all, thanks very much for watching. I'll see you in the next video.